let's solve a few questions from the chapter Construction of Geometrical Figures and Coordinate Geometry. Now, let's move on to the first slide. Construction of triangle. So first, we have a few construction questions. We have to construct a triangle when length of sides are given. Construct a triangle XYZ given that XY equal to 6 centimeter, XZ is equal to 8 centimeter, and YZ is equal to 10 centimeter. Right? So I'm taking 10 centimeter YZ as the base. You could take it anything. So we have YZ is equal to 10 centimeter, right? Now we have to put XY is equal to 6 centimeter. So from here to the point X, it should be 6 centimeter. So I'll take 6 centimeter in my compass, place it on Y, and I'll draw an arc which is in 6 centimeter from here, right? Now XZ is equal to 8 centimeter. From Z, the distance to the point X is equal to 8 centimeter. So I'll just, again, I'll have the, I'll take the compass in 8 centimeter. I'll draw an arc here. I'll get a point like this, and this would be X. So I'll join all 3 points by lines. Right? Now we'll get a triangle whose sides are 6 centimeter. XY is equal to 6 centimeter. YZ is equal to 10 centimeter, and XZ is equal to 8 centimeter. Now, construct a triangle PQR given that PQ is equal to 5 centimeter, QR is equal to 6 centimeter, and angle PQR is equal to 60 degrees, right? So we have PQ is equal to 6 centimeter and angle PQR. So QR is taken as the base. So QR is the base. Now the base we'll draw it for 6 centimeter. Take a ruler and draw it, right? Now from Q, we'll take a protractor. Angle PQR is given. So the angle is at Q. So we'll place the protractor here, right? We will measure 60-degree angle and we'll mark the point of the angle here, right? Now we know that QR is equal to 6 centimeter, right? Now QR, let's draw a 6 centimeter QR. No, we have PQ is equal to 5 centimeter, right? So we'll draw a P from here to 5 centimeter. We'll mark it here. 5 centimeter is marked here. Now we'll join this point and this point, right? And we'll join Q. So we'll get a line. And then we got this point which is P. And then we'll join P and R. So we'll join P and R. And we get the triangle PQR whose angle is 60 degree. One side is 6 centimeter, other side is 5 centimeter, right? Now, let's move on to the next question. Construct a triangle ABC given that angle BAC is equal to 40 degrees, angle ABC is equal to 80 degrees, and AC is equal to 7 centimeter. So let's draw the line AC first. We have AC equal to 7 centimeter, right? Now what do? We'll take a protractor, we'll place it on A. We know that angle BAC means angle A, right? So angle A is equal to 40 degrees. Angle BAC means angle A is in between of B and C. So B would be somewhere here, C would be here, angle A would be 40 degrees. We'll keep the protractor here, mark 40 degrees from here, we'll put a point, right? Now, we'll take ABC, we'll extend this line, right? Now we'll put the protractor at the end of B, right? And we'll measure how many degrees? 80 degrees. We'll measure 80 degrees, right? And we'll join it from B to C and we'll get a triangle ABC. With this angle would be 40 degrees and this angle should be, this would be a little bit more here and it would be 80 degrees. Right now, then we'll have, basically this is an included side. So 7 centimeters should be in the middle of this. So it would be great if we could make it in a different way. Like we'll take a baseline first. We'll draw a random line AB first, AB. Then from there we'll measure 40 degrees. And then we know that side AC is equal to 7 centimeter, right? And if we put C here, angle BAC would be 40 degrees, right? So we'll put C here and we'll mark 7 centimeter from here to here. And we got C here and then we'll join these both sides and angle BC ABC So this would be AC is equal to 7 centimeter, and we have BAC and ABC, it's same only, right? So we have 7 centimeter as AC, and we have angle ABC is equal to 80 degrees, right? Now, construction of length of a right angle triangle. Construct a right angle triangle DEF given that DE is equal to 9 centimeter, DF is equal to 12 centimeter, right? Now, EDF is a right angle triangle. So, this would be EDF, and we know that D angle is the right angle. So, this is the right angle, right? Now, we have what all given? We have angle DE and DF, the sides are given. So, we'll draw a line which is of 9 centimeter, right? And what do? We'll put the compass here. We'll draw a line EDF. So, ED, right? And this would be F. So, we'll mark a point to 12 centimeter here, and then we'll join this line at 90 degree and we'll get a right angle triangle. Now, construct a quadrilateral W, Y, X and Z given that WX is equal to 5 centimeter, XY is equal to 4 centimeter, ZX is equal to 7 centimeter and WY is equal to 8 centimeter. So, 4 sides are given. It's very easy to construct a quadrilateral when 4 sides are given and the diagonal is also given. So, the quadrilateral is WXYZ. So, we place WX first, 5 centimeter, and the coordinate diagonal is WY. This is WX. Then from W, I'll mark 8 centimeter apart, right? Now, this is my diagonal and this point would be Y, which is 8 centimeter, right? Now, I have XY is equal to, we'll mark a point here and this would be 6 centimeter, right? Then YZ, I'll mark a point which is 4 centimeter away from here, and XZ. So, this would be Z. So, this would be the XZ would actually be the, if I put it this way, WXYZ is our quadrilateral, right? So, we have WX drawn first, then we have XY, XY is 6 centimeter, then we have YZ which is 4 centimeter, and we have XZ, yes, XZ is equal to 7 centimeter and WY. We have 2 diagonals are given. So, we'll draw the 2 diagonals too and then we'll get a quadrilateral, right? So, we'll mark anything as the base, like we could take anything, right? Now, we have WX, XY is given as 6 centimeter, drawn 6 centimeter arc here, right? So, this is 6 centimeter. Now, we have YZ, I'm marking 4 centimeter from Y, this is here, this is Z and this would be 4 centimeter. Now, we have ZX equal to 7 centimeter. We'll draw 7 centimeter from here and complete the arc, and WY is equal to 8 centimeter. We'll take 8 centimeter and complete the arc here. Now, we'll join all these 4 points and we'll get a quadrilateral, right? Now, moving on to the next question, construct a quadrilateral ABCD given that AC is equal to 7 centimeter, BD is equal to 9 centimeter, AB is equal to 6 centimeter, BC is equal to 5 centimeter, CD is equal to 4 centimeter and AD is equal to 8 centimeter. So, what all do we have here? We have 2 diagonals and 3 sides. So, we have a quadrilateral ABCD, right? So, we'll take the AB as 6 centimeter, AB 6 centimeter. Now, we have BC at 5 centimeter. So, from B, I'll put the composite B and mark a 5 centimeter arc. Now, if this point is C, I have CD at 4 centimeter and AD is equal to 8 centimeter. So, from A to D, I have 8 centimeter, right? Now, we have an arc AC is equal to 7 centimeter. So, from A, I'll mark 7 centimeter here, which I'll get a diagonal, which is 7 centimeter. Now, I'll join this line to B, I got CD, right? Now, I have a diagonal BD 9 centimeters. So, I'll put my composite B and draw an arc here, and this would be the point D. This would be at a distance of 9 centimeter from B, right? We'll join all these 4 sides and we'll get the required quadrilateral. Now, in the Cartesian coordinate system, which quadrant contains points with positive x and negative y coordinates? So when we were talking about coordinates from in a Cartesian system, we had this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. So we have 0, 0 or origin here. This is x, this is minus x, this is y, and this is minus y. So which quadrant contains points with positive x and negative y? For first quadrant, it was positive x and positive y. Second quadrant, it was negative x and positive y. Third quadrant, it was minus x and minus y. And fourth quadrant, it was like x and minus y. We need positive x and negative y, so it's the fourth quadrant. The answer is fourth quadrant. Now, what are the Cartesian coordinates of the point located at the intersection of x-axis and y-axis? So we know that this is the Cartesian plane. We have x, y and minus y. Where do x and y intersect? It intersects at 0, 0 at the origin. 0, 0 is also called the origin. Now let's move on to the next question, which is the distance between point P35 and Q79 is. So we have 2 points which is given as P with the coordinates 3 and 5, and we have Q with the coordinates 7 and 9. Now we have to find the distance PQ. So we had a distance formula. Distance is equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square, right? So PQ is equal to root of, what is x? So this is in the form x1 y1, right? And this is in the form x2 y2. So what is x2 here? It's 7. And what is x1 here? That's 3. So we have 7 minus 3 the whole square plus y2 is 9 and y1 is 5. So 9 minus 5 the whole square. So we have PQ is equal to root of 7 minus 3 is 4. So we have 4 square plus 9 minus 5 is also 4. Again 4 square. So we have root of 16 plus 16, and that is equal to root of 32. So the distance is root 32, right? Now the midpoint of the line segment with endpoints A is 2, 6 and B 10, 18. So we have a point A which is equal to 2 and 6 as the coordinates, and for point B the coordinates are 10 and 18, right? Now we have to find the midpoint of the line segment. So what is the equation of midpoint? So midpoint is ordered pair x1 plus x2 by 2 and y coordinate is y1 plus y2 by 2. So here this is x1 and y1 and this is x2 and y2, right? So midpoint is equal to, what is x1? 2 plus x2 is 10 by 2 and y coordinate is y1 is 6, y2 is 18 by 2, right? Now what is 10 plus 2? 12 by 2 is 6 and 16 plus 8. What is 16 plus 8? We have, no, 6 plus 18. We have 18. We have 18 plus 6. So this gives us 14 and 24. This gives us 24 by 2, which is 12. So the coordinates are 6 and 12, right? X coordinate is 6 and y coordinate is 12. So the answer is 6 and 12 actually, not 12 and 6, it's 6 and 12, right? Now let's move on to the next question. If the point P 4 minus 3 divides the line segment AB in the ratio 2:3 and A is 1, 2, then the coordinates of the B are. So here this is a tricky question. Why? We have the line segment AB. The coordinate of A is equal to 1, 2. We don't know the coordinates of B, but what is given? There is a line segment, there is a point P which have a coordinate 4 and minus 3, which actually divides the line segment AB in the ratio 2:3. This is the way it divides the line segment, right? So we could say that 4 and minus 3, we have a section formula where if a point P divides the line into m is to n, the coordinates of P would be mx2 plus nx1 by m plus n would be the x coordinate, and y coordinate would be my2 plus nx1 divided by m plus n by 1, right? Now, this is actually given, the coordinates is actually given, right? So, what is m? M here is equal to 2, n here is equal to 3, right? Now, what is x? x1 and x2 is, x1 is 1 and y1 is equal to 2. Now, we have to find what? We have to find this one. We have to find x2 and y2. So, we have to find x2 and y2. So, for this, we know that m2, x2, I don't know, so we'll put it as x2 plus n is 3, x1 is 1, 3 into 1 divided by m plus n, 2 plus 3 is 5, is equal to 4. 4 is given as the point of P. So, we have 2x2 plus 3 is equal to 5 into 4 is 20. So, we have 2x2 is equal to 20 minus 3, which is 17, right? And we have x2 is equal to 17 by 2, which is, let's see, we have 17 by 2, we have 8 2 is 16 and 1 0, so 8.5 is x coordinate, right? And for y2, let's find out y2. So, we have m is equal to 2, y2 would be here, and 3, y1 is 2, divided by m plus n is 5, which is equal to minus 3, right? So, this becomes 2y2 plus 6 is equal to minus 15. Now, 2y2 would be equal to minus 15 minus 6, that will get us minus 21, right? So, y2 would be equal to minus 21 by 2, right? So, we have minus 17 by 2 and minus 21 by 2 as two coordinates, right? So, the answers given is wrong here. So, the answer for this question is minus 17 by 2, no, 17 by 2 and minus 21 by 2 are the coordinates of B, right? Now, let's move on to the next question. The coordinates of a point are minus 5 and 12. In which quadrant does the point lie? So, we have minus 5 and 12. So, it's minus x and y, right? So, in 4 quadrants, when we talk about it, here it's x and y, here it's minus x and y, here it's minus x and minus y, and here it's x and minus y, right? All in brackets. Now, what are the coordinates? Minus x and y belongs to second quadrant. So, the answer is second quadrant. Now, let's move on to the next question. What is the distance between the point A 3 minus 4 and B minus 2 5? We have to be very careful about the signs in this because the negative sign becomes another quadrant, right? So, what are the coordinates of A given? It's 3 and minus 4, and coordinates of B given is minus 2 and 5, right? We have to find the distance, and the distance formula, distance is equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square, right? Now, this would be equal to root of x2 is minus 2, so minus 2 minus 3 the whole square plus 5 minus minus 4 the whole square, right? This would give us minus 2 minus 3 is minus 2 plus minus 3, which is minus 5 the whole square plus 5 minus minus 4 is 5 plus 4, which is 9 the whole square, which is equal to root of 25 plus 81. We'll get 6, and 8 plus 2 is 10. So, it's 106, root of 106. So, this is actually 106, root of 106, right? 106 is the answer. So we have 3 minus 2, or even if we do the opposite, we'll get the same. Why? We have root of 3 minus 2 is 3 plus 2, which is 5 square, plus minus 4 minus 5 is minus 4 plus minus 5, which is minus 9 square, which is equal to 9 square. It's the same thing. 5 square is 25 and 9 square is 81. We have 6 and 10, so it's root 106. Right? Now, the point P divides the line segment AB with coordinates A is A2, 8 and B 6, 18 in the ratio 1:2. Find the coordinates of P. So we have P, which divides the line segment AB, where the coordinate of A is equal to 2 and 8 and coordinate of B is equal to 6 and 18 in the ratio 1:2. So what all do we have here? We have x1 is equal to 2, x2 is equal to 6, y1 is equal to 8, y2 is equal to 18. We have m is equal to 1, n is equal to 2, m plus n is equal to 3. So how do we get the points of P? We have mx2 plus nx1 by m plus n and my2 plus ny1 by m plus n. So here we'll get P is equal to, what is m? M is 1 into x2 is 6 plus n is 2, x1 is 2, m plus n is 3. Now what is m? M is 1, y2 is 18 and n is 2, y1 is 8 divided by m plus n is 3. So we have 6 plus 2 into 2 is 4, so 6 plus 4 by 3, and we have 18 plus 16 by 3, right? So we have mx2 plus nx1 and then we have my2 plus ny1, right? So this would be 10 by 3 and 18 plus 16, 18 plus 16, this would be 14 and this would be 34, 34 by 3, this would be, this is not divisible and this is not divisible. So the answer for this question is 10 by 3 and 34 by 3. If we are simplifying, we'll get 3 point, 3 3s are 9, 1 0, 3.333, and when we are simplifying this, we'll get 111 point, let's see, 1 0, 1 and 1, 1 0, so 11.333. So the closest answer here is 3 and 12, right? But the right answer is 3.33 and 11.33. This is the answer. Now let's move on to the next question. The point minus 3 and 7 lies in which quadrant? Again, we have 4 quadrants, x and y here. We have minus x and y here. We have minus x and minus y here. And here we have x and minus y. So minus 3 and 7 means minus x and y, which lies in the second quadrant. Now these were a few questions from the chapter Construction of Geometric Figures and Coordinate Geometry. You have to solve out questions from this chapters a lot, and especially in the construction part, you would have to do the construction by yourself on a piece of paper. Like, you have to practice the construction questions in order to do it very easily. So this is all about the chapter Construction of Geometric Figures and Coordinate Geometry.